Okay. Seems like it's a little loud. Knock it down just a little bit. We still want the jams, but we don't want them that loud. Actually, what I really need is... Let's just switch this out real quick. I don't think that's gonna work. Yes, it will work. Knock it down just a little bit. We still want the jams, but we don't want them that loud. Actually, what I really need is... There we go. Now I'm gonna move it over to the side. That should be totally fine. Just kind of testing everything. We are working on the Network Plus from CompTIA. And just make sure the audio is good. Oh yeah, we need to kind of test this, make sure that this works.
Perfect. You're taking exactly the right approach to prepare for Network Plus. Deep understanding, not memorization.
Nope, that's not what I want. I need this to be, and that should work.
Is what will make this stick for both the exam and the real world.
There we go. Now it should be doing both. We'll test it out in a second. Anyway, we are working on Network Plus. We're working on the very first section. The very first section is the longest section. It's the longest section. If there's something wrong with the audio, just let me know. There's 8 subsections inside of this one section, which is just network concepts. We're going to try to get through every single one. I've already done a lot of these, so it's going to be kind of like a big refresh course for a lot of us, or at least for me. So let's just go ahead. Let's dive in. And I am going to... let's test the Speechify. Let's see. Sometimes it needs a few go.
Which of the following functions are performed by the OSI transport layer?
Okay, cool. I think that's good. So which of the following functions are performed by the OSI transport layer? So the OSI model, in case you don't know, there's 7 layers to it. Hold on. Little test. Perfect. Okay, cool. I'm always worried about the audio because it's hard for me to hear. Just in general from drums. Let me move this. I don't know where to move this. We're going to move this down here. And we're going to make this... we're going to make this bigger. We'll make this here. And then we're going to make this a little bit bigger. Yeah. Oh, look at that. Going off screen. That's what I like. I dig it. You know, you think you have all this stuff set up and everything's going to go fine. And then you find like little things like, hey, it should be like this or it should look like this. Okay. Okay. So the OSI model. The OSI model has 7 layers to it. It's the layer 1 is physical. Layer 2 is data. Layer 3, oh my god, I don't remember. Layer 3 is something. Layer 4 is transport. So it is going to be considered data formatting between no data segment. It's going to be reliability. And we're going to kind of like go balls to the wall with this one. Like there's not going to be a lot of sure's or unsure. It's going to be like sure. So, end-to-end flow control, reliability message delivery, and consistent data formatting between dissimilar systems. Data segment and I'm going to say here. Let's go. Okay, good. I am going to do this one real quick. Well, no. We're going to go through it first, and then we'll review things. We'll see where our knowledge is first.
An organization has asked a network administrator to research and submit a purchase order for new network access points. The network administrator is attempting to choose between using wired and wireless access points. Which layer of the OSI model is the administrator making a decision?
Okay, so we have the physical layer, we have the data link layer, we have the network layer. The session layer is layer 5, I believe. Physical, data link. So it's physical, like the wires themselves. Man, I'm going bald. The wires themselves, the data link layer, because just because two computers are connected with an Ethernet cord does not mean that they know that they're connected. You have to like make sure that they know by typing in the IP address. The network layer is like routers and stuff. The layer above that is transport. I think transport also takes care of quality control too. So he's worried about, okay, I'm gonna say data link layer. Wrong. I bet it was network layer. No, I bet it was physical layer, because he was wondering between a wired and physical is like all hardware based. Okay, anyway, we'll continue. What do we got?
Which open systems interconnection OSI layer assumes responsibility for managing network connections between applications?
Assumes responsibility for managing network connections between applications. The network layer. Buddy, it's not going well.
Which OSI layer assumes responsibility for managing network connections between applications?
Between applications? The application layer. I'm glad that we're reviewing this, because right now I'm 1 for 3.
What is the role of an access control list, ACL, at layer 3 network layer of the OSI model? To act as a routing protocol for determining the best path for data packets. To serve as a list of permissions for file access on the network. To define the maximum size for packets transmitted across the network. To filter network traffic by permitting or blocking packets based on IP addresses and other criteria.
It's either this one or this one. I'm going to go with this one. Dang it. Good review session.
A network administrator is looking at an ARP table on a switch for connected devices. Which open systems interconnection OSI layer are they looking at?
So they're looking at ARP table, then they're looking at layer 2. And layer 2 should be the data link layer. Yes! Alright, let's go.
Which of the following protocols reside at the application layer of the Open Systems Interconnection OSI model? Select 2.
Which of the following protocols resides at the application layer? I'm pretty sure it's at the application layer. See, the top layers is where I get confused. This is core fundamentals of Network Plus. It's not looking good for the home team. At the application layer. Maybe that's layer 5. We're about to make a diagram, boys. Okay, I'm going to say SMTP. Which of the following protocols is at the application layer? I'm going for it. Nope. Let's learn. Alright. I have a feeling that I have all of these layers all mixed up. And that's okay. We'll let that do its thing. I guess these don't have to be right next to each other. Yeah, that doesn't matter. Alright.
The physical layer of the OSI model is responsible for the transmission and receipt of the signals that represent bits of data from one node to another node. The network layer is responsible for moving data around a network of networks, known as an internetwork or the internet. The data link layer is responsible for transferring data between nodes on the same logical segment. The session layer, layer 5, represents functions that administer the process of establishing a dialogue, managing data transfer, and then ending or tearing down the session.
My T's in the way. Can't type. Give me a diagram. I want to see a diagram. That's what I'm talking about. Let's see this thing. All right, what is the OSI model? No, I want the... There it is. Physical, data link, network, transport, session, presentation, application. So if I remember correctly, physical is the computer itself, wires, that stuff. Data link is... Our two computers, the two computers are connected, but they don't know they're connected. So this is like your switches, like putting in your actual IP address. The network layer is routers. So now you're connected to the outside. You're connected to the WAN. Okay. Transport layer. This is TCP, UDP, I believe. The session. This is making sure that like you're talking correctly, like duplex, that type. Well, duplex is technically layer 2, but it is the conversation. It's making sure that it's stable from the beginning, the middle, and the end. Oh, it's all coming back. It's all coming back. Presentation layer is making sure that it is the correct format, I believe. And then 7 is HTTPS, like the actual, like stuff like that. Okay. So, what was the question again?
An organization has asked a network administrator to research and submit a purchase order for new network access points. The network administrator is attempting to choose between using wired and wireless access points.
So this is why this question is tricky, because it says he's trying to choose between wired or wireless. Wireless would not be a physical thing, but we're talking about the actual device itself. Since we're talking about the device itself, we're talking about physical layer. Let's we're not going to listen to all of this, but
let's break this down using your preferred structure. 1. Restate the 4. In-depth explanation. The OSI model has 7 layers, and the physical layer, layer 1, is the one responsible for the physical transmission medium, including cables for wired access points and radio waves for wireless access points. Here's how each layer relates to the question. Physical layer deals with the medium of transmission, copper, fiber, wireless signals. This is exactly where the decision between wired versus wireless happens. Data link layer handles MAC addressing, switching, and framing.
Yes.
But assumes a physical medium is already chosen.
Yes.
Network layer in charge of routing and IP addressing, how data moves across networks.
Okay, so this is also a little tricky. It says it's in charge of IP addressing in terms of the WAN, not in terms of like local. Not in terms of like if you want to have a LAN party with like your Xbox 360, if you're old enough for that. That would be connected through the data link layer. If you wanna play, well, it's not really Xbox Live anymore, but if you want to play it live, if you want to play like a service game, a live service game, that's where the IP address is gonna come.
But not the medium itself. Session layer, higher level layer that deals with opening, managing, and closing communication sessions, not related to physical infrastructure decisions. 5. Real world example or scenario. A network administrator is setting up connectivity in a large building. They're choosing whether to run Ethernet cables to each floor for wired access points, or mount wireless access points that broadcast Wi-Fi using radio signals.
Just know that a wired connection will always be better than a wireless connection. I don't care how fast Wi-Fi will ever be. The wire connection will always be faster. It just will. It'll just always be faster. Now, that doesn't mean that Wi-Fi is bad. It just means that if you have the option and you have the ability to, you should always be wired. You should always be hardwired in. Okay, cool. Next.
Which Open Systems Interconnection OSI layer assumes responsibility for managing network connections between applications.
We just learned here the session layer is a high level layer that deals with opening, managing, and closing the communications. That is the so I was right. So the session layer is all about the start of the video call, maintaining the video call, and then ending the video call. Okay? And I'm using video call as an example, by the way. Okay? So the question is responsible for managing the network connection between applications. So I can make that make sense. I can do some mental gymnastics to make that make sense, but let's...
Most application protocols require the exchange of multiple messages between the client and server. This exchange of such a sequence of messages is called a session, thus the session layer. Sessions can work in 3 modes: simplex, half-duplex, or duplex. Some form of transmission...
Okay, now it's correct that the session layer deals with those duplexes. So that's about how the data is received. Like, think about like walkie-talkies. If I have a walkie-talkie and you have a walkie-talkie, and you can't talk while I'm talking, because that is simplex. Yes. So that means I can only talk and you can only talk. Duplex means that we can talk at the same exact time. Now, just because we're talking the same exact time, we might not hear each other like physically because like we're talking over each other, but the internet is able to move those those packets and get it across the line. Like your cell phone can do that. Okay. But the reason that's interesting, or the reason that can be tricky, is because you set duplex on the switch, and the switch is a layer 2. So the switch, although a layer 2 device, handles things that are layer 3 and handles things that are layer 4. Okay, and that is layer 4, correct? No, it's layer 5. Okay, so there are layer 5 protocols inside the switch or inside the router.
Simplex, half-duplex, or duplex.
Oh, come on, do the thing.
Some form of transmission or physical media creates a link between network nodes. The physical layer of the OSI model, layer 1, is responsible for the transmission and receipt of bits from one node to another node. The network layer, layer 3, transfers information between networks. It is the session layer that manages connections between applications. The data link layer, layer 2, transfers data between nodes on the same logical segment, whereas the session layer manages connections between applications.
Okay, that makes a lot of sense. Let's keep going.
Which OSI layer assumes responsibility for managing network connections between applications?
I thought it was the application layer, but I was wrong. It is the session layer. Responsibility for managing network connections between applications. That's the session layer because it's the start of the video call, the middle of the video call, and the end of the video call. However, I am going to put this in here because I think it's going to kind of review a little bit of what all these things do. Where is... You are sure and you are sure and incorrect. What a slap in the face. All right.
The session layer is responsible for establishing the connection, maintaining sessions, authentication, and ensuring security. Network applications implement the application layer. These applications produce data, which has to be transferred over the network. The data link layer, DLL, is responsible for the node-to-node delivery of the message. When a packet arrives in a network, it is the responsibility of DLL to transmit it to the host using its MAC address. The network layer works to transmit data from one host to the other located in different networks. It also takes care of packet routing from the number of routes available.
I have never heard the data link layer called the DLL.
Let's unpack this carefully with your full breakdown format. 1. Restate the question. Which layer of the OSI model is responsible for managing and maintaining network connections between applications? 2. Simplified answer. Session layer. 3. Analogy. Imagine 2 people having a phone conversation. The application layer is each person talking. The session layer is the act of starting the call, keeping it connected, and hanging up at the end.
Yes.
The network layer is the route the signal takes through phone lines. The data link layer is making sure each piece of audio data is delivered without corruption. So managing the connection itself. The network layer is the route the signal takes through phone lines.
That's okay. Okay, so that also makes sense what I was talking about. The network layer is the IP for the WAN, but it's the more in-depth answer is that it's the route that it's actually digitally taking. Okay?
The data link The session layer, layer 5 of the OSI model, is responsible for establishing, managing, and terminating communication sessions between applications. Key responsibilities: session establishment, setting up the rules for communication like authentication and permissions. Session maintenance, keeping the session alive, managing synchronization like checkpoints and file transfers. Session termination, cleanly shutting down the connection when done. The other layers mentioned: application layer.
The session layer is also where UDP and TCP happen. And the difference between TCP and UDP is how they deliver packets. So TCP like checks packets and makes sure that they're delivered correctly. There's like fail safes, and if something goes wrong, it's like stops and it's like, yo, what's going on? Like something's not going correct. The UDP is like, bro, here's all your packets. Just go, 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 go. And that's how streaming is done. Streaming is done through UDP. That's why I don't know if you've noticed, but like my camera sometimes lags. I don't know why my camera lags in terms of my system setup. I'll have to figure that out. But in terms of UDP, it's because it's sending packets. Some packets are corrupted. Some packets are not working right, or are missing something, or maybe they got thrown into the wrong order. But because it's a live feed and it's never stopping, it keeps going and it doesn't stop. And then it just eventually it figures it out by just having new packets. This is how like live service games work, and why you experience lag. It's because packets were received in the wrong order, or weren't received at all, or corrupted, or something like that. Okay.
Layer 7 interfaces with the user and applications, for example, web browsers, email clients, but doesn't manage the connection itself. Network layer, layer 3, handles logical addressing and routing IP addresses, not application sessions. Data link layer, layer 2, deals with MAC addresses and frame delivery on a local network, not sessions between applications.
Yeah, local network.
5.
Okay.
Real-world example or scenario. Imagine you're using Zoom to have a video call. Zoom, the application, connects using layer 7. The session layer sets up the session, negotiates encryption, keeps the session alive during the call, and ensures everything shuts down properly when you hang up. If the session drops and reconnects, that's the session layer trying to maintain content.
Okay, understood. So which OSI layer assumes responsibility for managing the network connection between applications? Not the application layer, that was stupid. It's the session layer. Maybe I should have reviewed this thing a little bit before. Physical data network, which is the route. Transport. No, transport's got to be TCP, UDP. Okay, so I'm a little confused on where TCP, UDP fall. Maybe there's a... see here. What is the OSI model? Okay. Defines format data network. Transport is TCP UDP. That's important to know. All it does is maintain, but this is what's transporting the data. What's interesting is that the OSI model is technically obsolete. We use the TCP model, which is right here. However, people immediately, where'd the picture go? People immediately connect it with the OSI model, and all it really does is that it just combines things: network access layer, network layer, transport layer, and then the application layer. So it just kind of combines them. But I don't think we're going to be asked anything about that. What's going on here?
What is the role of an access control list, ACL, at layer 3 network layer of the OSI model?
See, I told you, it was one of these two. I mean, that doesn't change the fact that I get it wrong, but...
To filter network traffic by permitting or blocking packets based on IP addresses and other criteria.
What's hard is that there are multiple acronyms that are exactly the same that mean completely different things, like ARP, for example. Okay, let's see what we have here.
At layer 3, ACLs are used to enforce security policies by filtering traffic. They determine which packets are allowed to pass through a network device, such as a router, based on rules that include IP addresses, protocol types, ports, and other criteria. ACLs do not define packet sizes. This is typically managed by the network protocols in use, such as TCP/IP. ACLs are not routing protocols. Routing protocols like OSPF or BGP are used to determine the best path for data packets.
ACLs do not define packet size, which is typically managed by the network protocols in use, such as TCP/IP. We're just gonna skip over that.
ACLs at layer 3 do not manage file access permissions. They control network traffic. File access permissions are typically managed by the operating system or file system.
Okay, so that makes sense. Access control list. What does it do? Well, it controls the access based off of IP addresses. It blocks or permits based off your IP address. Next. See, okay, I almost clicked HTTP, but HTTP is like not safe. So like, I was like, oh, it's got to be a trick, right? This is why like you also have to have test taking skills. Taking tests is hard, man. Like you have to actually know the material, and then you have to be smart enough to read a question and know what it is actually asking.
Which of the following protocols reside at the application layer of the Open Systems Interconnection OSI model?
So
Select 2.
The application layer. So do we still use HTTP? I mean, technically, yes, we do. However, if you try to pull up any website that's HTTP, your phone's going to be like, hey, this is not a secure website. You sure you want a thing? You sure want to proceed? And 9 times out of 10, like, it'll actually be difficult to get your phone to push past it to be HTTP and go through it. Okay, you want HTTPS. So I know that. I know how that works. So I was like, well, there's no way. Like, yeah, that operates on the application layer, but why would I do that? Well, it's not asking about what's common practice or anything. It's asking just a cold question. What resides in the application layer? Well, that's HTTP and SMTP, which I don't quite remember what STMP is. So let's do it.
Layer 7 application layer works at the user end to interact with user applications. QoS, quality of service, file transfer, and email are the major popular services of the application layer. This layer uses the following protocols: HTTP, SMTP, and FTP. SMTP protocol resides at the
File transport protocol. SMTP. I think that's to deal with email.
SMTP. SMTP protocol resides at the application layer, layer 7. This is the layer at which many TCP/IP services high-level protocols can run, which also includes FTP and HTTP.
Okay.
Layer 3 network layer performs real...
I don't know what SMTP is. I don't remember. So let's just Google it real quick. SMTP, which stands for Simple Mail Transfer. I knew it. It has to do with email. Okay. Yes. Because there's another one. It's like IPOP or something. There's like 3 or 4 ports when it comes to email. Some of them are really old. And one of the reasons why the mail, like in the old Windows 10 and even a little bit of Windows 11, the old mail app, the reason that sucked and no one used it is because it used an old email port. Now you could have changed it and like done stuff, whatever, but like if you didn't know what you're doing, like, and it didn't work straight out of the box, meaning that you actually had to go and hit a sync button. It would download all of your emails. And this is how email used to work. You would download all of your emails and then you would go through them all. Unless you were connected to the internet 24/7 or you were connected to the actual server or whatever. This is where the phrase like I didn't get that email came from, or I haven't read that email yet. It's meaning that you literally hadn't downloaded it onto your device yet. So yeah, emails come a really long way. Okay, so it makes total sense. IP is IP address. STMP is just a protocol, so that's why that's one. Why is it not TCP? I think that's the transport layer.
The transport layer, or host-to-host layer, establishes connections between the different applications that the source and destination hosts are communicating with using the TCP and UDP protocols.
All right, cool. Next.
Which Open Systems Interconnection OSI layer assumes responsibility for managing network connections between applications?
It's the session. Let's go.
Which of the following protocols reside at the application layer of the Open Systems Interconnection OSI model?
Okay, at the application layer, that's SMTP. We just did it. Okay, TCP is session layer stuff. That's where like how files are transferred, like UDP and TCP. IP is your internet address, and then HTTP. So many acronyms, man. So many acronyms. And it's the context of it too.
An engineer troubleshoots a network connectivity issue that the server team reported. The engineer notices that the trunk port is down between two routers.
Ooh.
After checking the fiber link on the router, the engineer moves the cable and notices that the link light comes on. The issue is most likely a part of what layer of the OSI model?
So this is how taking the test works. So a question always has multiple parts to it. So one, it's the scenario, or in this case, it is the scenario. So it's setting it up like, okay, he's troubleshooting. We don't need to know he's an engineer, but obviously he's an engineer. Okay, network connectivity issue. This is the problem. There's a network connectivity issue. Okay, he describes what the problem is. The problem is that the trunk port is down. This will make you think that it is another answer. Okay, but that's not what it is. The next part of the question that gives you the most amount of information of what it's actually asking is right here. After checking a fiber link, which is a physical connection on the router, the engineer moves. So it means he physically moved. He wasn't like typing or anything like that. Notices that the link light comes on. So that means that we're dealing with the physical layer. Man, wouldn't I look like a clown if that was wrong? Okay.
Character encoding, data compression, and encryption, decryption take place at which OSI layer?
Ooh. Character encoding, data encryption, or compression, encapsulation, decapsulation, or de-encryption. Oh my gosh, I cannot read. Take place at which OSI model or layer? I'm going to say the application layer. Final answer. Oh, dang it. I don't know what it would have been.
What is the role of an access control list, ACL, at layer 3 network layer of the OSI model?
Okay, so it's access control list. Usually they do exactly what you think they do. So I need to do a better job of not overanalyzing things. So access control. So that means it's controlling the access and it's a list. Okay, makes sense. So that means that it's going to filter network traffic and it's going to permit things or not permit things, meaning block packets, based off of IP addresses. Of course, if you have any questions whatsoever, always drop them in the chat. I should be able to see them.
Character encoding, data compression, and encryption, decryption take place at which OSI layer?
See, I almost hit presentation layer, but presentation layer is not the last layer. I got these two mixed up. I thought it was application and then presentation. So it is the presentation layer. That makes total sense.
In the presentation layer, the data from the application layer is extracted and manipulated as per the required format to transmit over the network. Translation, encryption, decryption, and compression are some of the functions at the presentation layer. Network applications implement the application layer. These applications produce data, which has to be transferred over the network. The session layer is responsible for establishing the connection, maintaining sessions, authentication, and ensuring security. The transport layer provides services to the application layer and takes services from the network layer. The data in the transport layer is referred to as segments.
Okay, I don't know what happened there, but whatever. Okay, cool. I did this because I wanted the analogy and I wanted the in-depth explanation. We don't really need it to, the only reason I'm having it restate the question is just for memorization's sake. Not that I'm trying to memorize the questions, but if I these are very common things that are going to happen on the job, right?
Let's dive in and clarify this. It's a 3.
Analogies make the world go round.
Think of two people sending letters in a secret code. One writes a message application layer, then encodes it into a cipher and compresses it to fit into fewer pages presentation layer, and finally sends it through the mail system lower layers. So the presentation layer is like the translator and encoder decoder. It ensures that the message can be understood once received. 4. In-depth explanation. The presentation layer, layer 6, is responsible for formatting and translating data so that the application layer, layer 7, can understand it, regardless of the systems involved. Its core responsibilities include character encoding, converting data into a standard format like ASCII or Unicode; data compression, reducing the size of data before transmission, for example, zipping files; encryption, decryption, making sure data is secure in transit and readable on the other end, for example, TLS SSL encryption. Let's clarify what the other layers do. Application layer, layer 7, provides services and interfaces to users like web browsers or email, but doesn't process formatting compression. Session layer, layer 5, manages sessions between apps when connections stop, but not data formatting. Transport layer, layer 4, ensures reliable delivery via TCP UDP.
All right, give me a
It
real
moves
world
the data,
scenario.
but
Let's
doesn't
go.
care about how it's encoded. 5. Real-world example or scenario. You send an email using a secure webmail client. You write the message application layer. Before it's sent, it gets encrypted, so only the receiver can decrypt it, and may be compressed for efficient transfer. That's the presentation layer in action. Then the data goes through the lower layers to be delivered. Another example, streaming video on Netflix. The presentation layer compresses video, for example, H264, ensures the encoding is standard, and handles encryption so only authorized users can watch. Final answer, presentation layer.
I just had a huge light bulb because I do a lot of video editing, obviously. And H.264, that, like when you export in Premiere Pro, really anywhere, it's always, you have to do H.264. And I was like, oh, that's super fancy computer talk for MP4, which it is, but like now it makes sense because of the presentation layer. Now, why it does that in Premiere Pro and it doesn't just say MP4, I don't know. But that's not what we're doing. Okay, let's keep going.
An organization has asked a network administrator to research and submit a purchase order for new network access points. The network administrator is attempting to choose between using wired and wireless access points. Which layer of the OSI model is the administrator making a decision?
So again, it's strong test taking skills. You have to be able to look at this and break it down to what it is. So this is the scenario. This is the point of what's going on, right? This is what's happening. It's a network administrator. He's researching to submit a purchase order. So that's a PO. He's trying to submit a PO in order to get new access points. Okay, so he's basically doing his job. The problem is that he is trying to choose between these two things. But that's like, this is just the problem. We don't know what the actual question is asking. The actual question, and you can tell because there's the question mark, everything else has been just a statement telling you what the scenario is. The actual question is, which layer of the OSI model is the administrator making a decision for? And the answer is physical.
Which Open Systems Interconnection OSI layer assumes responsibility for managing network connections between applications?
Session. Let's go.
What is the role of an access control list, ACL,
Access
at layer
control
3
list,
network
it's
layer
controlling
of
the
the OSI
access.
model?
Permitting or not permitting things based off of it being blocked by packets, or based off of IP address. Because what else would it base it off of? The entire internet can be summed up as IP addresses.
Which of the following protocols reside at the application layer of the Open Systems Interconnection OSI model?
Okay.
Select 2.
SMTP, which is something mailed transfer protocol. And then HTTP, I don't remember what that one is. I just know that's websites. TCP is transfer something protocol. And that's where it has things in case you lose packets. It'll resend it. And then IP address is your IP address.
Which OSI layer assumes responsibility for managing network connections between applications?
Managing network connections between applications is going to be session layer. Dang, I really thought I was going to get out.
Character encoding, data compression, and decryption take place at which OSI layer?
Presentation. I got these mixed up last time. All right. Not terrible, but also not good. Okay, look at it. Look at the hours I've spent on this. 37 hours compared to the all learners usually spend 4 hours. Like, and I started at 21%. Like, what is, whatever. Moving on to the next one. I think I hit what's smart refresh? What is that? Refresh by going through just the questions you struggled with, review, and your previous answers in the model. Let's do smart refresh. I think that's what we did last time too. Okay, here we go.
A company uses multiple internet providers to maintain a reliable network. The company's wide area network WAN interfaces with a firewall that handles the traffic bandwidth by using
Whoa, hold on. Multiple internet providers to maintain a reliable network. That's wild. Can you imagine having AT&T, Verizon, Xfinity, and Frontier? Like, how would that work with your modem? I mean, I guess it's different with the home,
policies. Considering the company's approach to internet access, what is one of the primary roles of the firewall?
the primary role of the firewall is probably going to be... Man, dude, I do not remember this at all. But I do remember struggling with this a whole lot when I went through it. I'm going to say VPN head-ended. No.
A network administrator needs to provide remote workers access to internal messaging servers, but cannot configure internal service at the perimeter network. What can the network administrator deploy to listen for client requests from the internet and create the appropriate request to the internal messaging server?
Ooh. Wow, dude. I do not remember this one. I think it's forward web proxy. Man, I do not remember this section at all.
A server technician is shopping for new storage for data on the business network. The storage requirement has risen over the last year, and the servers currently have limited space. Which of the following is an option for the technician to purchase to increase the available server storage on the local network?
I think it's a SAN. It's definitely not a VLAN. That's like something that you do in a router. It's not going to be a client server. So it's going to be one of these two. I'm going to go with the SAN. Yeah. SAN stands for... Shit, I can't remember. But basically, it has to deal with memory, and that's why SanDisk is called SanDisk. It's like that's why their brand is called that. It's a play on words.
A network consultant is reviewing header fields and is looking for evidence that packets are arriving at their destination. What is the name of the output ping that provides this information?
Time to live? Yeah. Okay. So it's slowly ingrained.
A junior-level systems administrator troubleshoots network connectivity. The results of the troubleshooting reveal a device that is new to the administrator. This device connects all hosts and routes network traffic. After evaluating the possibilities, and based on the device's characteristics, what does the network utilize for connectivity and traffic flow?
Ooh, okay, so a junior-level system administrator troubleshoots a network connectivity. The results of the troubleshooting reveal a device that is new to the administrator. Okay, this device connects all hosts and routers network traffic. It's not a multi-layer switch. So wait, this device connects all hosts and routers and routes. So it could be a multi-layer switch. I'm going with the multi-layer switch. Let's go. Yeah, that makes sense. So there are so switches in general are layer 2, but there are layer 3 switches. And honestly, what makes things so difficult when it comes to networking is that all these protocols and all these layers have their own individual devices for the most part. But at the same time, due to advancements in technology and convenience, a lot of times they are combined all into one device. So like when you go to Xfinity, you get that little gray box. That box is your modem, it's your switch, it's your router, it's your HDPC, H crap, what's it called? I forgot the acronym, but basically it divvies out and controls your private IP address. It's a NAT. You know, it's a whole bunch of things.
A managed
Your
service
Wi-Fi
provider is
too.
looking to set up a home network for a client and needs to set up a device that can connect to the client's internet provider. What kind of box should the consumer install for the client?
Okay, so a manager service provider is providing a setup for a home network for a client who needs to set up a device that can connect to the client's internet provider. What kind of box? Probably a router. Let's just read it one more time.
A managed service provider is looking to set up a home network for a client and needs to set up a device that can connect to the client's internet provider. What kind of box should the consumer install for the client?
Not a switch, because a switch only handles, unless it says, this is how you know if it's talking about a switch that's for layer 2 or a switch that's for layer 3. It will legitimately say layer 3 switch. Okay. Network interface card. That's just a NIC. That goes in your computer. Firewall. No, it's definitely router.
A network administrator needs to set up a circuit-level stateful inspection of traffic coming in and out of a specific segment of the network. What type of device should the network administrator use in this case?
So he needs to set up a level of stateful inspection. So a stateful inspection. It's not going to be a switch. Switch doesn't inspect anything. Switch is like the post office, like your local post office. The router is like the national post office. That doesn't really exist, but you know what I mean. A bridge is like connecting two access points. It's got to be firewall. I do not remember these questions at all. I'm totally just like using problem solving skills and the knowledge that's just been ingrained into me from doing this for so long.
A department in an organization asks a systems administrator to set up a small network for a test project that consists of 5 computers. The admin searches the storage closet for a spare device to make the connection. Considering the functionality of network connectivity devices, which of the following can satisfy the testing environment requirement?
Okay, so the department, and you might see things. I don't think you'll see it on the test or anything like that. And I'm not certified yet either. Like, that's why I'm doing this stuff. But I know that there's things that are called buses, and that is like predates the switch, and it's dumb. It can't handle like duplex and multi-duplex and things like that. So what's going on here is that they're trying the system administrator to set up a small network to test a project that consists of 5 computers. So a small project that consists of 5 computers, a switch is going to do it. All right, let's see what's going on with these that I got wrong.
A company uses multiple internet providers to maintain a reliable network. The company's wide area network WAN interfaces with a firewall that handles the traffic bandwidth by using policies. Considering the company's approach to internet access, what is one of the primary roles of the firewall?
Now, this makes this is again where I obviously overthought this question, because load balancer makes so much sense. If there's so many multiple internet providers, then of course it's going to be load balancer. Let's see what it says.
A load balancer can switch traffic to alternative nodes, reduce bottlenecks, and allow for failover services. In this case, the network engineer redirects specific traffic to take advantage of available bandwidth by using firewall policies.
Yep, that makes total sense. Let's see if we can. Where's the VPN thing?
A virtual private network (VPN) headend refers to the VPN router at a primary site responsible for aggregating high traffic volumes of remote sites connected via VPN in a hub and spoke topology.
Spoke topology. There you go. Vocabulary word.
A network administrator needs to provide remote workers access to internal messaging servers, but cannot configure internal service at the perimeter network. What can the network administrator deploy to listen for client requests from the internet and create the appropriate request to the internal messaging server?
We're going to go to chatbot-GPT for this one because I forget what a proxy is. I get it confused with like the actual word proxy. Now, I'm sure that they mean the same exact thing in different context, but yeah, okay, let's see what this says while we wait for chatbot-GPT to
A reverse proxy server provides for protocol-specific inbound traffic. This type of proxy can listen for client requests from the internet and create the appropriate request to the internal server. A voice gateway is a means of translating between a VoIP system and legacy voice equipment and networks, such as plain old telephone service POTS lines and handsets. A forwarding proxy server provides for protocol-specific outbound traffic. A web proxy must be able to parse and modify HTTP and HTTPS commands. An intrusion prevention system, IPS, can deploy as hardware or software to provide an active response after analyzing possible network threats that match signature patterns.
Okay. Let's get a good definition of a proxy. The authority or representation someone the authority to represent someone else, especially in voting. Okay, I see. That's the what I know. Like, I know politicians will use proxies. It's like a big deal, because how do you know that that proxy is like actually saying what that person is wanting to say, right? A figure that can be used to represent the value of something in a calculation. A figure that can be used. Okay. Proxy and networking. And then we're going to... a networking and proxy server acts like an intermediate between a client, like your computer, and a server, like a website. Okay. So now, let's go back here.
Great question. This tests your understanding of application-level intermediaries and how...
Yes.
1. Restate the question.
I know I'm great. Thank you, ChatGPT.
What should a network administrator deploy that can receive requests from remote clients on the internet, and then relay those requests to an internal messaging server, especially when the messaging service itself cannot be directly exposed to the public?
Okay, so that right there literally just was the same thing as the definition. This is literally the definition of a reverse proxy. Okay. Anyway, let's keep going.
2. Simplified answer. 3. Analogy. Think of a receptionist at a secure office. Visitors, remote clients, aren't allowed to walk straight into the office internal server. Instead, they go to the receptionist reverse proxy. The receptionist talks to the appropriate employee inside internal server, gets the information, and gives it to the visitor. A forward proxy is more like a personal assistant that goes out into the world on your behalf. The reverse proxy does the opposite. It receives requests from the outside and passes them in. 4. In-depth explanation.
Okay, I remember this. I remember going through this and thinking about it. You have to think about it in terms of a corporation, like how it just said, how there's a boss and a receptionist or an assistant, and then there's the outside. A forward proxy is where, like, Jeff Bezos wants to communicate to the world. I mean, do you think Jeff Bezos actually tweets? I mean, maybe he does. Probably not. He probably has someone to do it for him. He has a forward proxy where he's like, hey, I want to make this statement about this thing, make it sound good, put it in whatever kind of terminology it needs to be put into, and put it out to the masses. Okay? The opposite is for the reverse proxy. If I have a brilliant idea and I want to go talk to, I don't know, Elon Musk or Mark Zuckerberg or whoever, I'm going to go to the receptionist to relay my information, and that information will get to the boss, Mark Zuckerberg, Elon Musk, whoever. Now, the problem in real life is that you're not entirely certain if your information is actually getting to where it wants to be. In terms of technology, you know that your packets are getting there. Okay? All right, here we go.
A reverse proxy sits at the edge of a private network and handles requests coming from outside, usually from the internet, such as remote employees accessing services. It accepts incoming client connections, forwards them to the appropriate internal server, in this case, the messaging server, then sends the server's response back to the client. This is especially useful when the internal service cannot be directly exposed to the internet for security or design reasons. You need a secure access point that handles load balancing, authentication, caching, or SSL termination.
So like a school would use some type of reverse proxy to make sure that the sensitive information, I bet hospitals do the same thing, to ensure that sensitive information is not leaked out or just for security reasons.
Let's contrast it with the other options. Forward web proxy, clients use it to access external resources, like blocking certain sites. It
Right.
represents the client, not the server. Voice gateway connects VoIP networks to traditional phone systems, not relevant to general messaging or proxy services. Intrusion prevention system, IPS, monitors traffic for threats and blocks malicious traffic. It doesn't forward or relay.
So when it comes to the proxy, whether it be forward or reverse, it's about where the information is, who or what the information is coming from, and where's it trying to go. Reverse is outside going in, forward is inside going out. Clients use it to access the external resources. So clients meaning like employees. So a school teacher needs to access external resources. It's gonna be a forward proxy in order for them to access that stuff. That makes total sense.
Clients. Let's say your company has an internal chat server, like Rocket.chat or Microsoft Teams, that runs on a private subnet and cannot be placed in a DMZ. To let remote employees securely access it, you
DMZ is demilitarized zone.
deploy a reverse proxy like Nginx or HotProxy on a server in the perimeter network. Remote workers connect to the proxy via HTTPS. The proxy then forwards those requests to the internal messaging server and sends the response back. This setup keeps the internal server hidden from the public internet and allows for centralized traffic control and inspection.
That also is how a lot of content keepers are used for schools as well, I would imagine. Okay, so let's read the question one more time and then we'll move on.
A network administrator needs to provide remote workers access to internal messaging servers, but cannot configure internal service at the perimeter network. What?
Okay, so that's super fancy talk. We got to decode that. A network administrator needs to provide remote workers, so people who are not in the office, to access internal messaging servers. So they need to be able to access things. So you would think that a VPN would be the answer, but that's not a choice. Okay, but cannot be configured internal services at the perimeter network, meaning the actual network that is at the location. What can the network administrator deploy? To listen for clients' requests from the internet. So it's like the internal servers have like an ear out, like, hey, are you out there? Like, what do you? I'm listening for a very specific sound. This sound is my remote workers. Okay, and create the appropriate request. And that's why it is reverse proxy, because they are not in the building. They are remote. They are someone outside, and they are requesting internal access to whatever this is. Okay.
A company uses multiple redundant paths on the internal network to reduce.
Okay, multiple redundant paths. I'm already thinking that it is load balancer, but let's continue going.
A firewall installed in the company's demilitarized zone screened subnet includes multiple network interfaces that can systematically route traffic to these internal paths depending on bandwidth and other network policies. Considering the incoming internet traffic, what other purpose does this firewall serve as?
So it also might be content filter as well. A firewall installed in the company DMZ screened subnet includes multiple network interfaces that can simultaneously route traffic to these internal paths depending on the bandwidth and other network policies. So it can route traffic to internal places depending on the bandwidth, considering... Ooh. I'm going to go with content filter. It was load balancer. Wait. No, because a proxy server doesn't count for the DMZ. We just learned that.
A network administrator needs to provide remote workers access to internal messaging servers, but cannot configure internal service at the perimeter network. What can the network administrator deploy to listen for client requests from the internet and create the appropriate request to the internal messaging server?
Okay, so this is a reverse one because it said deploy to listen request for the internet to create an appropriate request from the internet messaging server.
Which of the following systems provide an active response to network threats that match signature patterns?
I'm like 90% sure it's SCAD. I cannot remember what SCAD stands for the life of me, but I remember that it has something to do with like security. Nope, I'm wrong. Which of the following system provided an active response to network threats that match signature patterns? I think it's IDS or IPS. I don't know. We'll find out. Staring at it ain't gonna do nothing.
What piece of network equipment allows network engineers to allow or deny traffic to specific locations within the network?
Firewall. Which piece of network equipment allows network engineers to allow or deny traffic to specific locations within the network? So it's trying to trick you with the router. Well, no, because it says or says deny traffic to specific locations within the network. Within would be well, it doesn't necessarily have to be a switch, but we're talking about network equipment that allows network engineers to allow or deny traffic to specific locations. Let's think about this one. It's an equipment that allows engineers to allow or deny traffic to specific locations within the network. I don't think the switch has the ability to deny. It can't filter. Cat, I'm in the middle. I'm in the middle of thinking. I'm in the middle of thinking. I'm gonna go with firewall. Because firewalls, I don't think routers can have a filter either. They filter based off of where things need to go, not based off of like security, not because it like denied you. The firewall goes onto it or is a part of it. Okay. Cat, you're driving me nuts. I'm about to kick you out.
A company uses multiple redundant paths on the internal network to reduce network latency. A firewall installed in the company's demilitarized zone screened subnet includes multiple network interfaces that can systematically route traffic to these internal paths depending on bandwidth and other network policies.
Okay, so I thought it was content filter because depending on network policies, that's what got me. It was network policies that made me think otherwise.
A load balancer can switch traffic to alternative nodes, reduce bottlenecks, and allow for failover services. In this case, the network engineer redirects specific traffic to take advantage of available bandwidth. The network engineer would use a proxy server as an intermediary for network access, such as internet access. A proxy can control what a system can or cannot connect to. Content filtering is a feature found in security appliances such as firewalls. The filter can block websites based on criteria such as topic categorization. A virtual private network (VPN) headend refers to the VPN router at a primary site responsible for aggregating high traffic volumes of remote sites.
It's like they all do the same thing, but yet in like different ways. And that's why it can be confusing. So the firewall, and this is another reason why I thought it was content filter, because it said a firewall installed in the company's DMZ includes multiple network interfaces. So you have to understand how these things interlock together, which I'm starting to kind of get. But like, if you don't understand that a firewall has or can have a load balancer with it, but a load balancer is not a firewall, like that's where it kind of gets dicey. And then understanding that a content filter is the same thing. Let's ask ChatGPT. Let's see here. No, let's say, how do firewalls, content filters, and load balancers work? How are they similar? And how are they different? And how do they work together? Make sure. A lot of people don't realize it, but it's like punctuation and stuff is super important when you're talking to an AI. Because it's dumb. Well, it's not dumb, it's smart, but you know what I mean. Fantastic question. Okay, while that loads, we're gonna close my door. All right, let's see here.
Fantastic question. Understanding how firewalls, content filters, and load balancers
Thank you,
function
ChatBot
individually
GPT.
and together is
Thanks for
foundational for the
the
network
confidence
plus
boost.
exam and real-world networking. Let's walk through this using your preferred format, and at the end, I'll provide a visual diagram to pull it all together. 1. Restate the question. How do firewalls, content filters, and load balancers work? What are their similarities and differences, and how do they operate together in a network? 2. Simplified answer. Firewalls block or allow traffic based on rules, IP, port, protocol.
Cool.
Content filters inspect and block, allow data inside the traffic like URLs, files, or words. Load balancers distribute incoming traffic across multiple servers to prevent overload.
Okay. So firewalls block and allow traffic based off of rules, IPs, ports, protocol, etc. That makes total sense to me. Okay. And a content filter inspects and blocks / allows data inside the traffic. This is the big thing. So it's one blocks and allows traffic in general based off of rules. The next thing inspects the data inside the traffic. This makes total sense because at the school that I work for, there are like YouTube is not blocked, but a ton of crap in YouTube is blocked. So the firewall allows YouTube so that way the students have access to it, but it filters out like I don't know what an explicit song or something. I know that's what a lot of kids talk about. Is like, I can't listen to my music. I can't listen to my music. This is my music. I can't believe I can't listen to my music. Well, maybe because your music has the F word every other word, and it's talking about like all sex and stuff. Maybe that's why you can't listen to it in class. But anyway, and then the load balancer is distributing incoming traffic. So the load balancer just distributes incoming traffic. I don't know what the order is. Let's see what it has. Ooh.
Fantastic question. Understanding how
Come on.
Similarities. All inspect network traffic and act as control points. Differences. They operate at different OSI layers and focus on different parts of the traffic.
That's the part I want to know. I want to know the order at which that it works. I know that it all inspects network traffic, but I want to know the order.
Together, they form a layered defense and performance strategy.
Okay.
Block dangerous items filters content, not just...
Wow.
Imagine a high-security office building. Firewall equal to security guard at the front door only lets people in who are on the list, IP and port rules. Content filter equal to bag checker looks inside what people are carrying to block dangerous items filters content, not just the sender. Load balancer equal to receptionist who tells people which floor to go to so no one floor is overwhelmed, balances traffic between servers. Each role is important. Together, they ensure both security and efficiency. 3. Analogy. Imagine a high security. Each role is important. Together, they ensure both security and efficiency. 3.
Cool. We're just going back to it. All right. Number 4, in-depth answer. We'll go ahead and how they work together.
4. In-depth explanation. Firewall. OSI layer, primarily layer 3 network and layer 4 transport. Function controls which traffic can enter or leave a network based on IP addresses, ports, protocols, TCP, UDP.
And that makes sense because ports and IP addresses are layer 3 and TCP UDP is layer 4, the transport.
P, types, packet filtering stateless, stateful inspection. Next-gen adds DPI, app layer controls, content filter. OSI layer, layer 7, application. Function inspects the contents of traffic, blocks websites via URL or keywords, scans email attachments, filters by MIME types or file types, common uses, preventing malware downloads, enforcing compliance, for example, blocking adult content. Email.
The times that my students say like, Mr. Milan, I'm going to download my malware. Why? I don't know. You can fix it, right? Probably not. Don't do that. Okay. So the firewall is an active part in the layer 3 and layer 4. Content filtering is at layer 7, the application, the very last layer. And this blocks websites because it's blocking. Oh, So when you're on your phone and you're trying to Google something and it says HTTP instead of HTTPS, it is the content filter. That is what pops up and says, hey, this is not a safe website. It got through the firewall. I don't necessarily know if your phone has a firewall, but it is the application layer that stops that. So it's preventing malware downloads. It doesn't know if it's malware or not, but it's stopping you from going there. Enforcing compliance, blocking adult content. Okay, that make like this like basic parental controls. Okay, email filtering, which I'm not gonna lie, my email filtering is not good. Just FYI, there are tons of local singles in my area who are ready to mingle.
Let's walk through this using your preferred format.
Okay, load balancer. Let's do it.
Load balancer. OSI layer can operate at layer 4 TCP UDP balancing or layer 7 HTTP's routing. Function. Distributes incoming traffic to a pool of servers. Increases redundancy and uptime. Can use metrics like round robin, least connections, server health. Types. Hardware like F5.
Hold on.
Software-based Nginx Load balancer. OSI layer can operate at layer 4 TCP UDP balancing or layer 7 HTTP's routing. Function. Distributes incoming traffic to a pool of servers. Increases redundancy and uptime. Can use metrics like round robin, least connections, server health. Types. Hardware like F5. Software-based Nginx proxy. Cloud-based AWS ELB, Azure LB. How they work together. Let's say you're hosting a secure web app for users worldwide. How they work together. Let's say you're hosting a secure web app for users worldwide. Firewall blocks all ports except 80 HTTP and 443 HTTPS. Only allows traffic from known IP ranges, for example, your office or partners. Content filter. Scans requests to make sure no malicious input or banned files get in. Filters users from accessing restricted parts of your site, for example, blacklisted URLs. Load balancer. Distributes incoming user traffic across several web servers to avoid crashing under load. Can also route based on content, for example, send all media traffic to one server, API to another. Together, they provide access control firewall, data scrutiny content filter, performance scaling load balancer. How they work together. Let's say you're hosting a
So does a load balancer help defend or protect against a DOS attack or a DDoS? Oh, look, they have a diagram.
5. Real-world example or scenario. You're a network admin for an e-commerce site. A firewall blocks all unnecessary traffic. Only port 443 HTTPS is open to the public. A content filter prevents users from uploading dangerous scripts in product reviews, for example, XSS attacks. A load balancer distributes 10,000 daily requests across 5 servers, ensuring uptime during flash sales. You now have security plus compliance plus performance working together. This is real-world layered networking in action.
Wow. Okay, so the internet, firewall, blocks unwanted IPs, ports, and traffic. Then we have content filter, blocking harmful URLs, files, and content. Load balancer distributes traffic across server, web 1, 2, 3. Summary, firewall, it operates on the layer 3 and 4. Content filter operates on 7. Load balancer is on 4 and 7. I want to know, this is going to be the last thing we do, and we're going to keep going. Does a load balancer help against, that is not how you spell against. What is going on? Against DDoS attacks. Excellent follow-up question. Let's walk through it. Restate the question. Simplified. Yes, a load balancer can help mitigate DDoS, but only to a point. It distributes traffic to prevent overload, but it is not a full DDoS defense on its own. So it's just kind of like it can do it a little bit. Okay, analogy. Imagine a popular concert hall with 5 entrances. A load balancer is a traffic cop directing fans to different doors so no one door is overwhelmed. Now imagine a DDoS attack as a flood of fake fans swarm the building trying to clog every door. Ah, like protesters. Okay, limitations, not a DDoS thing. Okay, real world example, load balancer helps. Okay. So it mitigates it. It by nature, it can help mitigate it, but it's not actually dedicated to do it. let's go back to what the original question was now that we've dived deep into this rabbit hole.
A company uses multiple redundant paths on the internal network to reduce network latency. A firewall installed in the company's demilitarized zone screened subnet includes
So right here, this tells me that it's load balancer.
A firewall installed in the company's demilitarized zone screened subnet includes multiple network interfaces that can systematically route traffic to these internal paths depending on bandwidth and other network policies. Considering the incoming internet traffic, what other purpose does this firewall serve as?
So it's making, the firewall is also serving as a load balancer as well. The content filter is not necessarily wrong. It's just not the most correct answer. And that's how these things go. It has to be the most correct answer. So a firewall is installed in the company's DMZ, includes multiple network interfaces that can simultaneously route traffic, which is load balancer, to these internal paths depending on bandwidth and other network policies. Network policies makes you think content filter, which is what happened to me. It is definitely not this. It is definitely not proxy server. So it is load balancer. Moving on.
Which of the following systems provide an active response to network threats that match signature patterns?
Do not remember what IPS is or IDS is.
An intrusion prevention system, IPS, can deploy as hardware or software to provide an active response after analyzing possible network threats that match signature patterns. Intrusion detection system, IDs, is like an IPS but provides a passive response to detected network threats using alerts such as notifications or emails. A supervisory control and data acquisition SCADA system runs as software on ordinary computers to gather data and manage plant devices and equipment with embedded PLCs called field devices. A virtual private network, VPN headend, refers to the VPN router at a primary site responsible for aggregating high traffic volumes of remote sites connected via VPN in a hub and spoke topology. Additional learn. An intrusion prevention system, IPS, can deploy as hardware or software to provide an active response after analyzing possible network threats that match signature patterns.
So it is an intrusion prevention software. See, this is why you have to know those stupid acronyms. There's a crap ton, and you gotta know all of them just about. Okay, so if I would have known what that acronym was, this would have been an easy win. You know, can deploy a hardware or software to provide an active response after analyzing possible network threats that match signature patterns. So basically, you have like predetermined, if you see XYZ, this is a threat, take it out. Okay.
Intrusion detection system, IDs, is like an IPS but provides a passive response to detected network threats using alerts such as notifications or emails.
Passive response to detecting threats using alerts. Okay, so this one attacks it and gets rid of it. This one just notifies you basically. Okay, which of the following system provides an active response? And that's how you know it's IPS.
A company uses multiple internet providers to maintain a reliable network. The company's wide area network WAN interfaces with a firewall that handles the traffic bandwidth by using policies. Considering the company's approach to internet access, what is one of the primary roles of the firewall?
One of the primary roles of the firewall is a load balancer, because it's filtering out traffic and it's pushing it out using the bandwidth into the correct doors. I hope that made sense. It made sense to me. I feel like I said that in like multiple different ways, like chunks, but yeah.
Which of the following systems provide an active response to network threats that match signature patterns?
Instant, delayed. That's not what that I actually stands for, but that's what I'm thinking. Instant, and then IDS is for delayed, meaning that's just going to give you a what you call it, notification.
A network administrator needs to provide remote workers access to internal messaging servers, but cannot configure internal service at the perimeter network. What can the network administrator deploy to listen for client requests from the internet and create the appropriate request to the internal messaging server?
So we have remote workers, so they're not on site. They're trying to access the internal messaging servers. So what does the network need to deploy? So that way the network is listening for client requests. So think of the receptionist. This is employees are talking to the assistant to get to the big man. Okay, reserve proxy. A reverse proxy, sorry.
Which of the following systems provide an active response to network threats that match signature patterns?
Active response, threats, signature patterns. Instant.
A company uses multiple redundant paths on the internal network to reduce network latency. A firewall installed in the company's demilitarized zone screened subnet includes multiple network interfaces that can systematically route traffic to these internal paths depending on bandwidth and other network policies. Considering the incoming internet...
Multiple network interfaces that can simultaneously route traffic. So it's doing other things, but it's routing traffic to these internal paths. So the firewall is acting not just as a firewall, but as a load balancer too. Just how a load balancer isn't a DDoS prevention, but it has a little bit with it as well, just by its nature. So by the nature of how they've set this up, it's also acting as a load balancer. Okay. Sweet. Number 3. We're knocking them out, boys. Oh, I don't like this.
Are planning a cloud infrastructure. After considering the available delivery models, the engineers decide to migrate and use a community model. Which of the following best is a primary characteristic of a community model?
Oh, I hate these because they're so... I don't even know. They're... Anything that deals with like cloud as a service and things like that, like, man, I suck at them because it's like I trick myself in my mind. I think that like I rationalize where it can be all of them. So engineers from a partner organization are planning a cloud infrastructure. They want to do a community model. A community model is like a doctor's office, basically. Like there's multiple hospitals and they all come together and they all pay for the same thing, but they're all separate, but they're all paying for the same cloud thing. So it's going to be shared costs. Yeah.
A cloud implementation for a growing business requires additional processing power. How will an engineer provide additional resources in real time?
Implementing scalability, implementing private direct connection to the CSP, implementing orchestration, implementing elasticity. I'm thinking scalability. No, scalability would be like you're growing, like your business and your company is growing, so therefore you need your cloud services to grow too. Maybe everybody had 5 gigs of their Google Drive, but now you have so many you have so many employees that by nature everyone needs to have more, so therefore the entire company needs to have more. That's what scalability is. So implementing a private direct connection to the SCP. So it is definitely not scalability. Elasticity is where you have a business that grows and shrinks. So like maybe you're something that has a peak season during back to school or Christmas, but then you go back to like normal. It's not that you're necessarily your business is shrinking. It's just that it fluctuates. I don't know what orchestration is. You know what, man? I'm going with the SCP.
An organization decides to retire an internal email infrastructure based on Microsoft Exchange Server technology. As a result, IT plans a migration to Microsoft Office 365. Based on IT's plan, which cloud service type best identifies the upcoming implementation?
Okay. Hybrid. So I can't remember the order of which one, but basically there's talking about, are your servers on location? Are your servers off location? Are your servers in a cloud somewhere else? Or is it a hybrid where you have some of your servers here, but it's also on the cloud? So what we need to know is the organization decided to retire an internet email infrastructure based on the Microsoft Exchange service technology. As a result, IT plans to migrate to Microsoft 365. My opinion, Microsoft 365 is trash. Based on IT's plan, which cloud service type best identifies the upcoming implementation? I cannot remember. Infrastructure as a service. This is also, I'm trying to remember because I don't want to, I need to remember. Infrastructure as a service is not Google Drive. That is service as a service? What does that S mean? I'm going to go with hybrid for the question. I don't really necessarily know what these mean. Also, by the off chance that I'm right, we're going to put it in chatbot GPT. Okay, I'm wrong. If I was right, it wasn't going to show me the question again. I wanted to reassure myself. The NAT question.
A medium-sized enterprise has recently expanded its operations, resulting in a significant increase in the number of employees. The company's network now includes over 200 devices that require internet access. The enterprise has been allocated a small pool of public IP addresses by their internet service provider, ISP. The network administrator needs to configure a NAT solution that allows all devices to access the internet without assigning a specific public IP address to each device. Which type of NAT should the network administrator implement to meet these requirements?
Okay. Port. So in real life, we would probably pick this one. That's like the modern solution. However, that's not what it's asking. It's asking what NAT should we use. A static NAT means that everyone... So what a NAT is that you have one public IP address, and it's either going to make multiple IP addresses and give them to them, or it's going to be... It's going to take that... well, okay. And those IP addresses, those private ones that it makes, are limited. Dynamic means that one person has it. So I have it until you request for it. And if you request for it, I either keep it, or when I'm done with it, I give it back and then it goes to you. That is... I know that that's the answer. I know that's what it wants. I don't remember what port forwarding is, because I thought port forwarding was the same as PAT. But I'm like 99% sure that it's dynamic NAT. Yeah. We're gonna... Because I remember when I originally studied this, chatbot GPT got it wrong as well. And I love it when chatbot GPT gets it wrong. Like, I'm not gonna lie. Like, that's not satirical at all. Like, I legitimately do. Because it proves to me that I'm thinking in a good way. What's happening? That I'm not stupid. That it tricked the AI as well, you know? I don't know why that is. There it is. Alright. Come on, come on. Yeah, static NAT means I think you have to assign it yourself, and it stays like that. Port forwarding means that the NAT makes ports for all the different devices, so that way it knows where it's at. So like you're all sharing one public IP address, and there's all these different like ports. But I thought that was port address translation.
This is a classic network plus NAT scenario, one that reflects real-world limitations like limited public IPs. Let's break it down fully. 1. Restate the question. A company has 200 plus internal devices needing internet access, but only a few public IPs from their ISP. Which NAT type allows all those devices to access the internet without needing a public IP for
ISP, internet service provider.
each? 2. Simplified answer. Port address translation PAT.
See, it got it wrong as well. It wants it to be this because that's the modern solution. That makes the most sense. Makes the most sense to my mind too, but that's not what the test wants.
Port address translation PAT.
The other thing too is that I'm going, as soon as it gives me this analogy and the in-depth thing of why it thinks this is correct, I'm going to tell it that that's not correct, and then it's going to explain how it got tricked by the question, and it's going to basically make sense why I got tricked by the question as well, although I didn't because I studied this. Okay, here we go.
3. Analogy. Think of a company with one main phone number, public IP, but hundreds of employees, private IPs, who all want to make outbound calls. Pat is like a receptionist who tags each outgoing call with a unique extension number port.
Yes.
When someone calls back, the receptionist knows who to send it to based on that tag. So even though there's only one phone number, all employees can share it simultaneously using different extensions ports. 4. In-depth explanation. What is PAT? Port address translation PAT is a type of dynamic NAT that allows many private IPs to share one public IP. It works by translating not just the IP, but also the port number.
Now, my question is I don't fully understand the difference between NAT and a DHCP server. A DHCP server takes one public IP address and it divides it out into multiple private IP addresses, and it gives out private IP addresses to all of your devices. So I don't know how that's different from a NAT. So we might ask that question too to make sure that we have clarity.
The NAT device maintains a translation table that maps make full copy edit 192.160.
We don't need it to read me all those numbers. So here's the IP address, and then there's the port number that it gave it. So NAT type. So PAT is a NAT type. Static is 1-to-1. Dynamic is many-to-many. And port forwarding is NA. Port forwarding. That's an inbound mapping port. So that has nothing to do with anything. So the reason it's saying it's not a dynamic is that it still needs a large pool of public IP addresses. In the question, it doesn't say how many IP addresses, it just says that it's limited and it's not going to equal out 200, which is why in the world would a company have an internet service provider that is just handing out public IP addresses to their employee devices. Like, that's wild. Okay.
5. Real-world example or scenario. Your company has 200 plus computers with private IPs like 192.168.0.x. You configure the firewall router with PAT. Every internal device goes out through 104.28.56.12. But with a unique source port, the router tracks all sessions so return traffic is sent back to the correct device. No one from outside sees your internal IPs, only the shared public IP and the ports.
Damn it, did I misspell guy? Oh, man. Let's see what it has to say about this. Great catch. Let's clear up the confusion between dynamic NAT and PAT, because this is one of the most commonly misunderstood topics in the Network Plus. You're right. CompTIA's objective list dynamic NAT separately from PAT, but here's the key. Short answer. PAT is technically a form of dynamic... Oh, PAT is technically... So this goes back to having a more correct answer. But the Network Plus and CompTIA terms, they are treated as distinct. Okay. Many to many. Here we go.
So why the confusion? Dynamic NAT requires multiple public IPs. It picks one from a pool. PAT uses one or few public IPs, but distinguishes sessions with port numbers. CompTIA separates them because they want you to recognize the difference in scaling. Dynamic NAT is limited to the size of the public IP pool. PAT allows thousands of users to share one public IP. If your question
So this is why I like doing this, because it's explaining to me why the question is worded the way it is.
came from a practice test or book that says dynamic NAT is correct for this scenario, it might be misinterpreting the scenario or following older wording that didn't clearly separate dynamic NAT and PAT. But according to modern CompTIA exam standards, for this situation, the enterprise has a small pool of public IPs but 200 plus internal clients needing internet access. The best fit NAT type is port address translation PAT, also known as NAT overload. Final clarification. PAT is a subset of dynamic NAT, but the key distinction is port level translation, which is required here to support 200 plus devices.
So it's still being like, but I'm still right. Okay. So the question is saying that there's a company with that now includes 200 devices and requires internet access. This is a dirty question, I'm not gonna lie. So what's the difference between dynamic NAT and PAT, and how does that relate to DHCP? Doesn't DHCP give out private IPs based on the one public IP that the internet service provider has given? So in the, I always forget how to spell scenario. So in the scenario, why wouldn't the DHCP server take over and give out more private IPs? I think this is a legitimate question.
Excellent. This is the perfect
love
deep
how
dive to really
ChatGPT
understand the
makes me
relationship
feel
between
smart.
dynamic NAT, PAT, and DHCP, especially in scenarios where you only have one public IP from your ISP but need many devices to access the internet. Let's walk through it with your 5-part format to lock it all in.
Lock it in.
Restate the question. What's the difference between dynamic NAT and PAT, and how do they relate to DHCP? Does DHCP give out private IPs based on a single public IP? And in that case, why wouldn't DHCP alone solve the issue? 2. Simplified answer. Dynamic NAT maps private IPs to a pool of public IPs, one-to-one, limited by how many public IPs you have. PAT allows many private IPs to share a single public IP, using port numbers to distinguish traffic, ideal when you have only one public IP. DHCP is completely separate from NAT. It just hands out private IPs on the internal network. DHCP does not give out public IPs unless you explicitly configure it to do so and have enough public IPs.
Well, okay, that makes total sense. So a NAT maps out private IPs to a pool of public IPs, one-to-one. That's stupid. If I have 5 public IPs, my NAT's gonna make 5 private IPs? Is this so that way I can constantly reuse those public IP addresses? And in which case, why would I not just reassign and assign again?
3. Analogy. Imagine you run a building with 200 apartments devices. The Postal Service gives you one mailbox, your one public IP. Now, DHCP equal to the landlord who assigns apartment numbers, private IPs to each resident. It just labels people. Dynamic NAT equal to you ask the post office for 200 unique mailboxes, public IPs. If you only get 5, only 5 residents can send, receive mail at once. PAT equal to everyone shares the one mailbox, but adds a code or name tag port number to each letter so replies get...
I'm just having a hard time understanding dynamic NAT. You ask the post office for 200 unique mailboxes. you only get 5. Only 5 residents can send and receive mail at once.
To the right apartment. 4. In-depth explanation. DHCP, Dynamic Host Configuration Protocol. Purpose: assigns IP addresses within a private network, for example, 192.168.0.x. DHCP does not use or know about public IPs unless you configure it that way. Think of
I thought DHCP... So DHCP just divvies out private IP addresses? Like, that's it? I mean, I guess so. And I guess it's not related to the... Oh, thanks, man. Can you chat instead? By the way, which game do you stream the most? So, I stream a lot of retro games like Mario and stuff. Thanks for the sub, by the way. I also play older games that are newer, like Halo. Do you plan on playing the new Donkey Kong when it comes out in a few days? Oh, I just kicked my cat by accident. Yeah, so I do stream a lot of old, like, retro games and stuff like that. I play a little bit of the newer stuff. Like, I'll play the finals and I'll play Fortnite sometimes, but mainly like Halo, things that are like kind of low key. Play a lot of Marvel Rivals. Also Marvel Rivals and stuff like that. And I do plan to play the new Donkey Kong when it comes out. Good question. All right, so back to the task at hand. DHCP, because I'm trying to think about how my setup is. My setup, give me, do some pirate software stuff right now. Okay, where'd my, okay. So my internet service provider, which has my public IP. That is connected to my Eero 7. My Eero 7 is connected to my switch. Okay? My Eero 7 is my DHCP slash, it's my router. Because it routes traffic and it hands out private IP addresses. Private. Okay, so I'm not. Hold on, we're connecting you to your channels. Weird. Switch private. Okay, DHCP. So that's how I'm getting my private IP addresses. And then this is connecting my private IP addresses. This is connecting my private IP addresses to and routing them back to my this. So it's not connecting it at all. It's basically like I have this one mailbox, and then I'm delivering it to all these other mailboxes that I'm creating. What's up, Black Mage? No, I don't normally stream daily. Oh, whoops. My fat fingers. Alright, so then if I had a NAT, it would be my one public IP address. So then how does that connect to the router? Okay, here we go. Let's go back to this.
4. In-depth explanation. DHCP, Dynamic Host Configuration Protocol. Purpose: assigns IP addresses within a private network, for example, 192.168.0.x. DHCP does not use or know about public IPs unless you configure it that way. Think of DHCP as internal only.
So DHCP only assigns private IP addresses to help regulate, well, to help create and regulate its private network. Nice. Nice. It's always good to be listening to me in the background. You need to know my voice. Okay? Okay, so now let's see dynamic.
Dynamic NAT requires a pool of public IPs from your ISP, for example, 5 IPs. Each internal device is mapped to one of the public IPs temporarily. If 200 users try to go out and you only have 5 public IPs, only 5 can be translated at a time. The rest are denied or queued. No port translation is done. It's a one-to-one IP mapping.
So to my knowledge, this means this means that dynamic NAT is like extremely inefficient. Oh, hold on, it's my mom. My mom's calling me. All right, enjoy the music. I have to call my dad. I will be back momentarily. Okay, so we're gonna have to kind of speed some things up. I gotta go with my dad somewhere. I'll be back on later today to finish section 1, most likely. Yeah. So let's see here. Favorite game? Honestly, probably Halo. I don't even know if Lewis 090 is on still, but anyway. Okay, I gotta understand this.
Dynamic NAT requires a pool of public IPs from your ISP, for example 5 IPs. Each internal device is mapped to one of the public IPs temporarily. If 200 users try to go out, and you only have 5 public IPs, only 5 can be translated at a time. The rest are denied or queued. No port translation is done. It's a one-to-one IP mapping.
So why would I use a dynamic NAT at all when I could have a router with a DHCP and private IPs? Seems like a dynamic NAT is like obsolete now. Crap, I don't even remember how to spell obsolete. Hold on. I'm all frazzled because I was set to do this until I went through every single one, and like now I have to go stop and do stuff. What was the word I can't spell? What was it? I don't even remember. It seems obsolete. OBSOLELE. Sure. I swear, if you're spam, you will get blocked. Or if you ask me to play some dumb game, you will get blocked as well. Okay.
Why DHCP alone can't solve it? DHCP only manages internal addressing. It can't translate internal IPs to public IPs. Without NAT or PAT, private IPs aren't routable on the internet. They'll be dropped by ISPs or internet routers.
Okay, so it sounds like DHCP is like the middleman between the nodes that are in a company and the public IP address. But it still seems like NAT is... It seems like that's still like obsolete. Obsolete.
5. Real-world example or scenario. Let's say you have one public IP, 73.40.250.513. DHCP assigns internal IPs, 192.168.0.2. John's PC, 192.168.0. Printer and PAT on the router. John's PC sends traffic to Google. Router rewrites it as 73.4250.513, 50,932. Jane's laptop sends traffic to YouTube. Router rewrites it as 73.42.50.513, 50,933. Return traffic is rerouted back to the correct internal IP using the port table.
See, this is what I'm saying. Like, why would you do this? If the 6th tries, it gets no translation and it gets no internet. So, but if it was, I guess I don't fully understand the connection between DHCP and NAT. With just DHCP, no NAT, all 200 devices have IP addresses, but none of them can access the internet. So is is PAT the thing that allows individual nodes that are on a private network to access the WAN?
Excellent question. And you're not wrong to ask if dynamic NAT is obsolete. Many pros ask the same thing. Let's break it down clearly. 1. Restate the question. If I already have a DHCP server giving out private IPs, and I can use PAT with a single public IP to get everyone online, why would I ever use dynamic NAT? Is dynamic NAT even useful anymore, or is it obsolete? 2. Simplified answer. Dynamic NAT is rarely used today because PAT NAT overload is more efficient and scalable. Dynamic NAT still has niche uses, but in most cases, PAT plus DHCP is the better, modern solution. 3. Analogy. Imagine you run a car rental business. DHCP equal to assigns license plates to cars on your lot, private IPs. Dynamic NAT equal to you have 5 parking permits, public IPs, that let cars leave the garage. Once used up, no more cars can leave. PAT equal to you have 1 parking permit, but allow all cars to use it at different times with color-coded passes ports. You can send out dozens with smart tracking. So why keep dynamic NAT at all? Only if you have a few devices and you don't want to deal with port translation for application reasons, like VoIP or legacy apps. 4. In-depth explanation. DHCP plus PAT, the modern standard. DHCP gives private IPs dynamically. PAT translates all of them to one public IP with different ports. Used in homes, small, medium businesses.
Okay, so that's what I thought. So PAT is the middleman that is between the DHCP server, or the DHCP, which is the private IP, and public. Question mark? What are you talking about, question mark? I have a feeling you're a bot. You have a lot of bot tendencies. I don't even know why I'm entertaining you. She said, can I ask you a question? I said, sure, what's up? And then you have a question mark. Also, your headphones are broken. Okay.
Dynamic NAT, what it does. Maps internal private IPs to a pool of public IPs. Requires enough public IPs to handle the max number of concurrent clients. If the pool runs out, new requests are dropped until a mapping frees up.
So then that's how my... Oh, I didn't realize that that wasn't showing. Okay, anyway. I'm not gonna jack with it because I'm gonna have to leave here in a second. Okay, next question. Okay, so well, hold on. We did a deep dive, and my parents called, and so we got a little confused.
A medium-sized enterprise has recently expanded its operations, resulting in a significant increase in the number of employees. The company's network now includes over 200 devices that require internet access. The enterprise has been allocated a small pool of public IP addresses by their internet service provider, ISP. The network administrator needs to configure a NAT solution that allows all devices to access the internet without assigning a specific public IP address to each device. Which type of NAT should the network administrator implement to meet these requirements?
So based off of if it was just a dynamic NAT, everybody would have private IP addresses. Yeah, everybody would have a private IP address. And then the dynamic NAT would just assign a public IP address to whatever those private IP addresses are whenever it was requesting to get out. So that way they could still do work within, but if it wanted out, which basically everybody needs out, so it makes sense why it's like why it's obsolete. That PAT is the new thing, because PAT is port address translation, which is why it's called port address translation, which is why that is the actual answer. Okay, that's interesting. Okay, so why is it rarely used? ISP change, charge for extra IP addresses. We also ran out of IP addresses like a long time ago. Your hold on, let me look at this real quick. Whatever. Okay. confused. You're waiting for public IPs in most cases when PAT. But now I can also see that there's another issue that's waning. If I'm using PAT, which means that my DHCP has given private IP addresses to all of my nodes. Everyone in the company has one. And then they are all assigned a port, so that way the PAT knows how to be the middleman between the private IP addresses and the public IP addresses. Now we have 200 people who are all trying to funnel traffic through the same public IP address. How is that managed?
5. Real-world example or scenario. Modern home office setup, PAT plus DHCP. DHCP hands out private IPs 192.168.1.x. PAT translates them to one public IP, for example, 73.112.5.22, with port rewriting. All devices can access the internet at once. This is default router behavior. Old style or ISP setup, dynamic NAT. DHCP assigns internal IPs. Dynamic NAT maps each to one of 5 public IPs. If 6 users go online, the 6th has to wait. Not scalable.
Yes, dynamic NAT is largely obsolete in modern networks. Most environments DHCP plus PAT because it supports hundreds of devices with one public IP address. It's cheaper, it's simpler, and more compatible. Dynamic NAT only makes sense in legacy environments, controlled labs, very specific protocol translation needs. No, I don't want that. I want to know I have one IP address and my DHCP makes 100 private IPs, and I have a PAT that gives out port numbers to the private IPs so that they can all use the same public IP address at once. How is 200 devices using the same public IP address handled, and how are packets not lost? So it says I'm gonna have to go in like 5 minutes.
Phenomenal question. You've just hit the core of how PAT, port address translation, works its magic. You're asking, if I only have one public IP, but 200 private devices are all browsing the internet, how does PAT keep track of who gets what data? And how does it prevent packet loss or confusion? Let's walk through this with your full 5-part breakdown. 1. Restate the question. If 200 devices are using the same public IP via PAT, and each device is sending and receiving packets at the same time, how does the NAT router keep track of everything without losing or mixing up data? 2. Simplified answer. PAT uses unique combinations of internal IP addresses and source port numbers to track every session. It maintains a translation table so that return traffic goes to the correct internal device. No packets get lost as long as there's enough port numbers and memory to handle the load. 3. Analogy.
Okay, I don't need an analogy. I understand it now. And that's why it thought that that was the answer, because it has now over 200 devices that require internet access. The enterprise is located in a small pool of public IP addresses. So it's trying this is why ChatBot says it's separating them so that way we understand the difference in terms of scalability. However, PAT has become the standard.
A company uses several Windows servers for Active Directory, SQL Server, Radius, DHCP, and DNS. Management is recommending a move to the cloud. IT suggests moving services in a staggered fashion so as to not cause disruption. Which of the following cloud architectures would best meet the migration requirements of the company?
Hybrid. Dang it. I lost connection because I was on the phone with my parents. Man, and I gotta go right in the middle. Oh no! I can't just continue? If I can't continue, then we'll call it. Okay, I can't continue. Okay, hybrid. Because man, and this is stuff that I really am not good at too. Come on, dude. Do the thing. Alt-A. Alt-A.
Cloud offerings, such as Amazon's Elastic Compute Cloud and Microsoft's Azure Virtual Machines, are examples of what type of service?
Infrastructure. Yes, infrastructure is virtual machines.
A network administrator is researching network virtualization and is trying to find a standard architecture for appliances to be developed against. Which of the following should the administrator consider as a standard architecture?
I don't know.
Which of the following descriptions best describes a public cloud infrastructure?
Third-party secure. Man, he's gonna be here. Shit, I hate when everything blows up all at once. It aggravates me to no end. Like, you have no idea how much it aggravates me when like 1,000 things I mean, it's just life, right? But still.
A cloud implementation for a growing business requires additional processing power. How will an engineer provide additional resources in real time? Elasticity refers to a system's ability to handle changes on demand in real time. A system with high elasticity will not experience loss of service or performance if demand increases.
I was wrong. I thought elasticity. Well, no, that's still technically the same. Changes on demand in real time. Because if you are experiencing seasonal stuff, that's changes on demand, just not super on demand. Maybe they're similar, maybe not. Okay, so cloud implementation for a growing business requires additional processing power. Okay. I have no idea when my dad's gonna get here, but when he does, I'm gonna have to jump off. Okay. This is the one that I really want to make sure that
An organization decides to retire an internal email infrastructure based on Microsoft Exchange Server technology. As a result, IT plans a migration to Microsoft Office 365. Based on IT's plan, which cloud service type best identifies the upcoming implementation?
So we have platform as a service, software as a service, infrastructure as a service.
Software as a service, SaaS, is a computing method that uses the cloud to provide application services to users. Office 365 is an example of SaaS. Platform as a service, PaaS, is a computing method that uses the cloud to provide any platform type services. An Oracle database is an example of PaaS. Infrastructure as a Service IaaS is a means of provisioning IT resources such as servers, load balancers, and storage area network SAN components.
This is where I was getting confused when I first did this, because Google Drive is a SaaS. It's a software as a service. It's not infrastructure as a service, because it has all of these softwares, but it also has storage.
Excellent. This is a very common exam question and a very real-world scenario. Let's go through it step by step using your preferred breakdown format. 1. Restate the question. An organization is retiring its internal Microsoft Exchange email servers and moving to Microsoft Office 365, which is hosted and managed by Microsoft. What type of cloud service model does this represent? 2. Simplified answer. SaaS software as a service. 3. Analogy. Imagine email as pizza. On-prem Exchange server, equal to you make the pizza at home from scratch. You own the kitchen servers, oven hardware, ingredient software, and do all the work. SaaS like Office 365, equal to you order delivery. Microsoft makes the pizza, bakes it, delivers it. You just eat, use the app. No kitchen needed. SaaS is fully managed. You don't worry about the servers, patching, uptime, or upgrades. 4. In-depth explanation. SaaS, software as a service. The provider Microsoft delivers fully functional software over the internet. You don't manage servers, OS, storage, or the app, just use it. Examples, Office 365, Gmail, Salesforce, Dropbox. In the question, you're no longer hosting Exchange on your own servers. You're moving to Office 365, which includes Exchange Online, managed entirely by Microsoft. You access email via web, Outlook client, or mobile apps. Microsoft handles everything else. Why the other answers are incorrect. Option why it's wrong. Here pass platform as a service equal to you manage the app. They manage the platform, for example, Azure App Services. You're not deploying or coding anything here. IaaS infrastructure as a service equal to you manage OS, apps, and data on VMs. Office 365 doesn't give you that control. It's fully hosted. Hybrid refers to combining on-prem and cloud resources. You're fully retiring Exchange, not keeping any part of it. 5. Real-world scenario. Your company moves from hosting your own Exchange 2016 server on Windows Server 2012 R2
I did not know
to Office 365
I did not know that audio was double. I apologize.
Exchange Online via Microsoft 365 Business subscription. Now, you no longer patch Exchange. You don't worry about mail flow, uptime, backups, or spam filtering. Microsoft handles it. You just use Outlook, webmail, or mobile apps. SaaS in action. Final answer, SaaS software as a service.
Okay, that makes sense. So let's read the question again.
An organization decides to retire an internal email infrastructure based on Microsoft Exchange server technology. As a result, IT plans a migration to Microsoft Office 365. Based on IT's plan, which cloud service type best identifies the upcoming implementation?
Okay. Not how they're going to do it, but how what they're going toward.
A company uses several Windows servers for Active Directory, SQL Server, Radius, DHCP, and DNS. Management is recommending a move to the cloud.
Okay, I understand this a lot better now.
Platform as a Service (PaaS) is a computing method that uses the cloud to provide any platform-type services. A SQL database is an example of PaaS. The PaaS architecture model would best meet the company's requirements. Software as a Service (SaaS) is a computing method that uses the cloud to provide application services to users. Office 365 is an...
Okay. We're gonna have to go a little bit faster than I'd like just because I don't know when my dad's gonna get here. When he gets here, I have to go.
A network administrator is researching network virtualization and is trying to find a
Everything's fine, by the way. Don't think that like I'm all frazzled because like something's going on. I'm frazzled because I'm in the middle of doing this and my dad wants me to drop everything to go go look at something that he needs help with. I'm not upset about helping my dad. I'm upset about having to stop in the middle of what I'm doing to go do something else because I'm trying to study. That's why I'm frazzled.
Standard architecture for appliances to be developed against. Which of the following should the administrator consider as a standard architecture? Virtual appliances might be developed against a standard architecture, such as Etsy's Network Function Virtualization (NFV). NFV divides provisioning into 3 domains. Typically, a hypervisor will implement network connectivity by means of one or more virtual switches, or vSwitch in VMware's terminology. These perform the same function as Layer 2 physical switches. In a virtualization host, the hypervisor manages the virtual environment such as virtual NICs and facilitates interaction with the computer hardware and network. Multi-protocol label switching (MPLS) is a means of establishing private links with guaranteed service levels. MPLS can operate as an overlay network to configure point-to-point or point-to-multipoint links.
Okay. Damn it. Okay, my dad's here, so I gotta go. I gotta go help him out with what he needs. No idea how long it's gonna take. We gotta go look at a bulkhead. But anyway, I hope you enjoyed the stream. If you did, like and subscribe, give a follow, all that stuff. I will most likely be on later today to finish this, and then I may or may not be streaming video games, something. Donkey Kong will be coming out soon. I think it comes out on the 17th, but I'll definitely be streaming Donkey Kong Bonanza, so I'm super excited about that. If you have any questions about anything, please like, subscribe, or please drop it down below. I'm going to be doing a lot more network stuff even after I take my exam. I'm going to be doing a lot more tech stuff in general. So if that's stuff that you like, you know, whatever, check it out. Tell a friend kind of thing. All right. I got to go. Makala Checo.